Now, how do we read a power supply specs and why do we care? Well, again, as much as I'd love to get into electronics, we don't have the time or the scope to do it. We do have an excellent course in the Pluralsight library on basic electronics that I'd encourage you to check out. But as I said, at the basic level, the power outage or the power capability of a PSU is given as an integer watts value. And watts is derived by combining the voltage that the PSU is capable to generate. In that case, we're talking about a 12-volt positive current, 5-volt, and 3.3. Those are the three to remember for computers. And amps refers to the amount of current that's actually flowing through a circuit. And again, those are directly related to each other. As one goes up, the other one goes up. They both function together to increase watts. This is a typical power supply label, and you'll notice that you'll see peak load such and so watts. I can't stress this enough. When you're building or upgrading computers for your customers, you need to be careful to make sure that you're powering all of the components in that system. If you underpower the computer by putting in a power supply that's too weak, you're going to, at the very least, cause system instability, and at the very worst, starve a device such that it shuts down or malfunctions. Notice also it says AC input 115 volts to 230 volts. In the United States, our household mains current runs between 110 and 120 volts. Most of the other areas of the world actually run at a much higher mains voltage in the vicinity of 220 to 230. Many times these ATX power supplies have a switch, an actual hard switch that enables you to go from one to the other. For instance, if you're taking a computer to another country. Be very careful to reset that properly because you will fry your entire system if you put a 115-volt system onto a 230-volt mains without switching the power supply.